little bit more basic, but then they get hard. So if you're looking at this, because it's a fraction exponent, I know my answer is going to turn into a radical. The bottom number becomes your index of your radical, which is the little tiny number. And then the rest of your power becomes the radicand, which is the thing underneath the root sign, like that. Perfect. Things I want to stress out that sometimes happen. Write your numbers nicely. Like take the time to write that 3 small. So it's right here. So it doesn't look like a coefficient out front. And like make sure it's small and it's right up in that little spot. Hey,
so does the denominator always stay the same?
Does the denominator always stay the same? Like when you're adding and subtracting things? Yeah. B. With B, I have to recognize what has a power that is a fraction. This thing has a power that is a fraction. So only that thing should be turning into a radical. The bottom number becomes the index. The rest becomes the radicand. This 2 out front was never part of the power. It was 2 times that power. So that means my answer needs to be 2 times that radical. So that's my final answer. Keep the 2 out front. This one. It's a fraction exponent. Fractions turn into radicals. The 2 right here becomes the index. The x to the power of 1 stays as the radicand. If you didn't put the 2 or the 1 and you put root x, that is perfect too. Remember, the 1 can be invisible, the 2 can be invisible. As if math wasn't hard enough, they make numbers invisible. D. There's a fraction exponent. Fraction exponents turn into radicals. The denominator becomes the index. The rest becomes the radicand. Like that. If we look up here at E, this is when it starts to get pretty tricky. So I'm looking at that thing. The entire power now has a fraction exponent. So that means this entire thing is going to go under the root sign. The 4 becomes the index. The rest of this stays here. Notice that I still have brackets around the 3x because I never use those brackets up. So it's bracket 3x bracket to the power of 2. And then that 2 needs to come into the brackets to become 4th root 3 squared x squared. If you change 3 squared to be 9, even better. Perfect. F. F is probably the hardest one on here. At least it's the one that we make like the most simple mistakes on. So the problem with F is that you have a negative exponent. And you have to deal with that negative exponent first before you deal with the fraction. So because it's a negative exponent, I have to make this a divide by 1 question. And I take the entire power and I move it under here. On the top, there's nothing left, so I put a 1 on top, so it's still a fraction. On the bottom, I now have x 1 over 3, like that. Then I deal with the fraction, but not until it's in the denominator. It becomes 3 to the power of x to the power of 1. That would be your answer. You have to have that 1 divided by on top. You have to. Otherwise, you're saying it's not a fraction, and it is a fraction now. G. To deal with G, you first have to add those things together. So that would be x to the power of 1 over 3 plus 4 over 3. When adding fractions, the top will add together to be x to the power of 5. The denominator stays as 3. If you think of it in terms of words, this is 1/3 plus 4/3. If I have 1/3 of something plus 4/3 of something, I have 5/3. 5/3. The bottom doesn't change, right? Just the top numbers do. You then change that into a radical. The 3 will be the index. X to the power of 5 is the radicand. The last one, this will be a subtraction question. So it'll be x to the power of 7 over 2 minus 4 over 2. Same idea. If you have 7 halves, which is what divided by 2 is, 7 halves of something minus 4 halves of something, you have 3 halves of something. So it's still divided by 2. The top number subtract, the bottom number stays the same. As a radical, that becomes the square root of x cubed.